is so on top of today's lecture where I'm going to finish up everything with transformations. So just to give an idea of everything that's due, the workbook is due today. The workbook assignment can be found in my math lab under course documents. You will see workbook 1. Please do that one and not not your workbook for now. We'll focus on the workbook next week. My assignment's a little easier, so that's why I'm recommending just do the one I typed up and put under course documents. So that's due tonight. For the homework pertaining to what we're going to be finishing today, that's due tomorrow. And an unfortunate consequence of the hurricane is that we have to catch up. And so the way that it was explained to me by the course coordinator is that you all have to watch a video lecture on your own accord. And that video lecture, so I made it last night. I already have it linked under the lecture links tab in my math lab. It's a lecture on quadratic functions and their graphs. So that homework is due Monday. And so to make up for this, the fact that you have to just watch this video on your own, which I'm not very happy about that premise, but it is what it is. To make up for it, on Monday during my office hours, I would do a homework review study session, and I'm happy to answer any homework questions you will have about that homework, if any. So it's my way of trying to compensate for the fact that we have to rush a little bit. And so I'll give out more information probably during class on Monday. I'll explain what time that will be and what all goes into that. So that would be for the homework Monday. You have to watch a video on your own accord. It's about an hour long. It's split up into 2 parts. So it's 60 minutes in total, and then might be a little bit more, but that should give you everything you need to know for the quadratic functions material that is due on Monday. And I'll probably end up sending out an email because that's quite a few due dates. It's workbook tonight, transformations and library of functions homework due tomorrow. There might be a quiz, I can't remember. And the quadratic functions homework due Monday. So just wanted to give everyone a heads up on that. So with that being said, let's go ahead and I'll go ahead and show my whole screen here, and we'll go ahead and pick up where we left off. So last time we talked about vertical stretching and compression. In general, we were talking about transformations of the graph, shifting and compression and stretching. And we were doing some problems pertaining to those. In example 2, we managed to get down to using the graphing tool to graph the equation. And pretty much we get this quadratic here. And here, and I just went ahead and rewrote all the things that we found. This graph goes to the right 3, up 1, and there's a vertical stretch of 3. And we went through a few of these last time for part C, or we might have finished it. I'm just going to go through it again just to be clear about it. So that's where we will pick up from. So here, so as I was explaining last time, for y is equal to x squared, the reason why they're choosing x squared is because that is the basic shape of the whole function. Keep in mind the whole function is right here. And so the basic function is y is equal to x squared. And if you plug in -2 for x, well, -2 squared is +4. Plugging in 0 for x, you just get 0 squared, which is 0. And 2 squared is 4. So that part's fairly easy. The corresponding points, that one was a little bit tricky, and that's why I wanted to go through this one again. And the reason why is because the corresponding points, so what does it mean for a point to correspond? So that initial point that was at -2 comma 4 over here, well, now that -2 needs to get shifted to the right 3 because we are going to the right 3. So that point needs to be shifted appropriately, shifted to the right 3. And so what happens if you take -2 and shift that to the right 3? You're adding 3. So -2 plus 3 is just 1. And that's why I'm putting a 1 right here. We're shifting to the right 3 because that's the number added to the x directly. And so that's why -2 would become 1. And so same thing with 0. That would become 3. And same thing with 2. That would become 5 because we take all of these and we shift to the right 3, where we're adding 3. It's a horizontal shift. And from there, we're plugging all of these points into the function that we highlighted up here. So if you plug in 1 into that function, you will get 13. So you could put all of that in the calculator. If you put 3 in there, you get +1. And if you put 5 in there, you will get 13. So that's what that means. It means that original point of -2 comma 4, how does that point transform after we apply all the transformations? Well, the x value shifted to the right, and then there's some output that corresponds to that. And so does anyone have any questions? And you can use your microphone if you have one. You're welcome to use it and ask me any questions. If not, or if you do have a question at any time, like I said, use your microphone. But anyways, move on to the domain and the range. So now that we know the graph, we can figure out the domain and the range fairly quickly. So let me go ahead and rewrite this. So the domain and the range. So remember the domain, since we have the graph, it's how far to the left can we go versus how far to the right we can go. And we use the x values. So I'll do this in red. How far to the left can we go? We hit an arrow, which means -infinity. To the right, we hit another arrow, +infinity. So that would be the domain. Now the range will not be all real numbers because the lowest point is not an arrow. The lowest point is that point that I just shaded in blue down there. So what is that point as an ordered pair? That seems to be the point 3, 1. We went to the right 3 and up 1. That's what we found when we did this problem last time. And so the range deals with the y values. So the y value here is 1. So it's going to be 1 with a bracket because that point is included on the graph. And from here, what's the furthest up we can go? Well, we hit the arrows. That's +infinity. And so that's how you would find the domain and range for this problem. So does anyone have any questions about this before I move on? If not, I'll go ahead and leave this on the screen while I talk about reflections. So reflections. So we've talked about shifting, which is moving the graph in one of the cardinal directions, as well as compression and stretching. So how much does the graph go in or out? But we've yet to talk about reflections. So if a graph which way a graph will flip, if that may be the case. And so visually, I think we all understand this. If we flip in one direction, we can all visualize that pretty easily, which is why graphs are helpful. But how does this apply algebraically? And so what about if we reflect about the x-axis? So that's what I was just demonstrating here. If you have a cup shape and you reflect about the x-axis, now it's shaped downwards. And if something's reflected about the y-axis, it would rotate as such. Algebraically, this is generally characterized by negative signs. And so to reflect about the x-axis, this is when you multiply the whole function by -1. It's when you multiply the whole function by -1. So if your whole function is multiplied by -1, then guess what? It's going to be the graph will be reflected across the x-axis or about the x-axis. For the y-axis, it's if the x variable is multiplied by -1, not the whole function, but the x variable. So if there's a negative sign in front of your x, then you're reflecting across the y-axis. So just like with the intercepts, it's kind of flipped. So negative in front of x means that y is flipped. Negative in front of the function, or y is negative, x flips. So let's kind of look at that in example 3 here. So we have some examples, and you can see there's negative signs in both problems. So let's see how to handle those. So with part 1 here, well, if anything, we're going to go ahead and determine all of the transformations, shifting, compression, and so on, and fill out the table down here as we did before. Now, if anything, I see +11, which instantly makes me think if you're adding a number or subtracting a number, this is going to be a shift up, down, left, or right, depending on where it's at. Since the +11 is happening outside of the function, then we know that we are shifting either up or down. And since this is up or down, then that tells us that we will go up 11. So we're going up 11. And additionally, so that would be the vertical shift. So actually, I just realized in this problem, it shouldn't be 11. It should be 5. So it should be up 5. So I forgot to mention that. That's just typo on my end. It should be 5. So just in your notes, just scratch out 11 and put 5. It should be 5. So it goes up 5 rather. And so, so if anything, that's the vertical shift. So now the question is, what about the negative here? Well, if the negative is in front of the x directly, then this will be a reflection about the y-axis. So it's a reflection about the y-axis. And that's because there's a negative in front of the x directly. It comes straight from the definition. If there's a negative in front of the x variable, we reflect about the y-axis. So the good news is the only interaction you have with this. So if anything, you have to choose the correct shape before the table even comes up. And this is a square root function because, well, of course, there's a square root. So if anything, we know that the shape is going to, in general, be this arc. If anything, that's the shape. So you select that shape, and then from there, you get the table. There is no vertical stretch or compression, so it should already say 1, and we're just going to leave it at 1. We reflect about the y-axis, so you would go and just check that off. You would just click that, and it will reflect the graph for you. And additionally, you go ahead and move the slider over to up 5. And if you do all of this correctly, you will end up getting this graph. And the reason why it's pointing in a different direction than the shape that I drew at the bottom is because we reflected about the y-axis. So this makes sense. If it's facing this way before, and then here's the y-axis, then it's going to face this way now. So again, MyMathLab does all of that for you. It will build the graph for you, which is very convenient as we get to the domain and range down here. So remember, the domain is left to right, and it deals with x values. What's the furthest to the left we can go? We see that there's an arrow, which tells us negative infinity. And what's the furthest to the right we can go? Well, we see it's this point right here. So what is that point? What is that ordered pair? Well, we can look and see that it's 0, 5. And since we're dealing with the domain, we're dealing with x values. So that's when we look at 0. The range, it's lowest point to highest point, and it deals with y values. The lowest point is right here in blue. And since the range deals, oh, I'm sorry, there's one thing. This 0 needs a bracket. Needs a bracket here because that point is included. So that does need a bracket. So as I was mentioning, the range, the lowest point is here where I shaded it in blue. And since we're dealing with y values, we will take the 5, which has a bracket because, again, that point is included in the graph. What's the highest point we can reach? Well, we hit the arrow. So that tells us infinity. So that would answer this problem here. Does anyone have any questions about part 1 here for now? So we'll move on to part 2 here. So part 2, it's just another equation that they give us. And we're going to start off the same way we did the previous part by determining all of the transformations. So I see the -2 here, which since we're adding or subtracting, that means shift up, down, left, or right. We are subtracting 2 from the function as a whole, which means we will be going down 2. This is down 2. Additionally, there is the 4 that is being added to the x directly, which would tell us left or right. In particular, it's the opposite, it's the direction opposite of the sign. So if we're adding 4, we go to the left 4. And finally, there is the negative sign here. And the negative sign, so this negative sign is in the very front, which means it's multiplying the function as a whole and not just the x directly. If it was multiplying the x directly, that negative sign would be in those parentheses, but it's not. So this means we reflect about the x-axis. We reflect about the x-axis. And so one caveat here is, so we have 3 different things that we need to fill in. If anything, the stretch or compression is still 1 because there's no number multiplying the function. So the vertical stretch or compression, that's just 1. So that should already be in there by default. So we do have the vertical shift and the horizontal shift. And so when you start to put these in, the order for which you put these in does matter. Because if you do down 2 to the left 4 and then you reflect, then you will end up having a different graph. So if anything, kind of the rule of thumb here is just to reflect first. Which means whenever you obtain this table here, the first thing you want to do is just check off the reflection. That's the first thing you want to do. After you do that, everything else you do is fine. So you reflect over the x-axis and you can move the sliders to correspond to the vertical shift and horizontal shift as we found before. You would also select the graph with the, so this is x to the 3rd, which is the snake shape. So really it's the snake shape. So you would select that one, or the cubic function shape. And that's from the library of functions page that we had. So the domain, well, we can figure out the domain and range after we have the graph. So it says take that snake shape. We're going to reflect about the x-axis and go down to the left 4. So again, you fill all this into MyMathLab and it will do it for you. So what you will end up getting is something that looks like this. And it makes sense why the graph is now going downwards instead of going upwards. And that's because we reflected about the x-axis. So we flipped it across the x-axis. And now that we have the graph, we can figure out the domain and the range fairly quickly. Luckily for us, there's no abrupt ends, as in if we go left or right, we get arrows. Furthest to the left gives us negative infinity. Furthest to the right gives us positive infinity. Furthest down for the range, negative infinity, and furthest up, positive infinity. And that would conclude that problem. Does anyone have any questions about this before we move on? If not, then let's go ahead and move on to the next question. So we only have 2 more questions left, and all the stuff on circles that you see, that's all taken out of the homework. So the circle stuff, so we're not going to worry about this page here. So we're going to do these 2 examples here. So from here, example 4 says, graph the following function using shifting, compression, and all of that stuff. Example 4, so everyone's going to get a problem pretty much just like this on the homework. I'm not particularly a fan of it because it's whenever you interact with the graph, you're not going to get the table where you fill in the vertical shift, the horizontal shift, and all of that stuff. Instead, what you end up having is when you interact with this graph, for the absolute value that is, the first point you pick will be the vertex, and the second point you pick will be just any other point on the graph. So it'll have you pick 2 points, and it will create the graph for you, which is different than our other problems. So we have to approach it a little bit differently. So if anything, I'd like you to follow along up to the extent of you be able to recreate this problem on the homework, be able to do the homework problem, and really just don't worry about this problem too much. So I'm basically telling you how to do it, in other words. And it's not a big deal if you don't know vigorously how to figure it out. But if anything, the shape of this thing, because you will have to pick out the shape, it's going to be a V shape. Because this is absolute value, and the shape of absolute value, as we saw in the library of functions page, is this V shape. Now we just need to figure out where this V shape goes. Where does it start at? In general, it starts right at the origin, but we need to figure out how much it shifts. So, if anything, when we look at this problem, you might think, all right, the shift is going to be +1. Because what this is the same thing as -x plus 1. So instead of 1 minus x, that's the same thing as -x plus 1. So you might think, all right, then we shift to the left 1. But that's not true. Because 1 is not being added to x directly, it's being added to -x directly. And the way we can fix that, I know this is one of the reasons why this one's kind of tricky, is we have to factor out a negative sign to now see that the reflection is truly going to the right 1. So that's what makes this one tricky. So if anything, that's where this graph will start at. And we don't go up or down at all because there's nothing being added to the function as a whole. There's nothing on the outside such as +4 or something. So if anything, we know that the graph starts here. You go to the right one time. Now, when you interact with this graph, yeah, the problem is it's not going to show that table. It's going to request that you plot another point. So all you have to do is find any other point on the function, any other point. That's it. It doesn't matter. It could be some point far away or close, as long as you can plot it on whatever graph they give you. Naturally, I just like to pick. So see, if we are right here, then I'm just going to pick x is equal to 2. Just 1 point over, 1 point over. And let's figure out what y is based off of this. So we're plugging in 2 for x. Again, we just need any point on the graph, any point at all. So 1 minus 2 is -1. The absolute value, remember, that means whatever's inside of it becomes positive. So that's why -1 becomes +1. And then it's just 3 times 1, which is 3. So in other words, when you plug in 2 for x, you get 3 for y. And that gives us this point right here. And by plotting those 2 points, the graph will be constructed for you. So from here, all we have to do is find the domain and the range. So the domain, it's how far to the left versus how far to the right you can go. The furthest to the left, we hit this arrow, and the furthest to the right, we hit this arrow. So this one's pretty easy. The range will have a little bit of exception because the lowest point is here. And so what is that point as an ordered pair? That seems to be 1, 0. Naturally, the range wants the y value. So that's why I'm going to pick 0. And I will use a bracket for 0 because that point is included. This is very similar to the cup shape that we had before, or even the square root shape that we had on the previous page. So the lowest point corresponds to 1, 0, the point 1, 0 down here at the base. And so we pick the y value from that because this is the range. And so the highest point, we see these arrows, which means a positive infinity. So that would be the domain and range for this problem. So if anything, all I'm asking is that you can recreate this on your homework to get this problem out of the way, so you can focus on other homeworks or other problems on the homework. Does anyone have any questions about this one before I move on? If not, then I wanted to change up example 5 a bit because I was getting a few questions about one in particular that I think is a little bit more pertinent to the assignment. So I'm going to change problem A. So ignore all of these. So part A, I'm going to ask, we'll shift up 5 units. Part B, we will reflect about the x-axis. And then we'll reflect about the y-axis. So we're just changing that problem entirely, because I've gotten a few questions already about this problem. And it's for one reason. I'll explain why in a bit. So what it's wanting us to do is take this problem, or take this function of y is equal to the square root of x, and delete that. So it wants us to take this function here and, well, apply the transformations one at a time. So we're going to start off by taking that function and shifting up 5 units. So the original function is the square root of x. And how do we shift that up 5 units? Well, that means we have to add 5 on the outside of the function. Just like that. So we add 5 to the outside of the function. That's how we shift up 5 units. So far so good. That part isn't the tricky part. It's the next problem, or the next part, that is the tricky part. And so since we're applying these transformations sequentially, we want to take that last part, that last result that we had, and now find a way to reflect that about the x-axis. Now, when you reflect about the x-axis, so remember from before, what that translates to is we make the whole function negative. So naturally, you would think, okay, well, I make the whole function negative. I put a negative sign in the front. This is not correct. This is the part where students mess up on. It's not just as simple as putting a negative sign out in the very front. What you have to do to make the whole function negative and not just the first term negative is use a set of parentheses upon applying the negative sign, because that negative sign needs to distribute. So really you would end up getting negative square root of x minus 5. So that's what you are doing. And so the negative sign distributes, and we would conclude with, at least for part B, negative square root of x minus 5. And this actually makes sense that even though we shifted up 5, now it looks like we're shifting down 5. Because if here's the x-axis, we shift up 5, so it's up here, then reflecting about the x-axis, it would be 5 units below. So this does make sense. And finally, we'll go ahead and reflect about the y-axis. So we take the previous result, and to reflect about the y-axis, that means we have to make the x variable negative. So that means within the square root, we will put a negative on the x as such. And this would be the answer after we apply all the corresponding transformations. Does anyone have any questions about this so far before we find the domain and the range? So if not, then let's go ahead and find the domain and the range. So the interesting thing here for example 5 is we don't have a graph. So for the domain and the range, we will have to construct a rough sketch of the graph. And to do that, we will need to figure out what the square root of x looks like. So originally, the square root of x looks precisely like this. So now we need to take that original form and shift it up 5 units, and then reflect that about the x-axis, and then reflect that about the y-axis. Which means you take that center point that I emphasized on the graph there. So this point I'll color it in red. If we shift that up 5 units, 1, 2, 3, 4, 5, and then we reflect around about the x-axis, which means that point would then become down here. And as long as we correspond the shape with all the reflections, then what we will end up getting is this shape right here. So that would be the corresponding shape after all the transformations are applied. You would shift up 4, and then you would reflect about the x-axis, which means your up 4 would now be down 4, or 5, I'm sorry. Up 5 would be down 5, and shifting about the y-axis would take your arc that was on this side, I think from your perspective, this side, and then flip it over. So upon getting this, now we can figure out the domain and range simply by visualizing it. So the domain is left to right. The furthest to the left we can go, we hit an arrow, which is corresponding to negative infinity. The furthest to the right we can go seems to be this point right here, which is the point 0, -5. So with the domain, naturally, we want to find the x value. So that's why we use 0 with a bracket. With the range, it's simply lowest to highest, and we use the y values. Lowest point is the arrow, which goes towards negative infinity. The highest point is where the square root function ends, and the range wants the y value, which is -5. And so that would conclude this problem as well as this section. So this should be everything you would need in order to complete both the library of functions homework, which is very easy. There's a bunch of people who have already just went through and completed it. And the graphing with transformations homework, which is what all of this stuff pertains to. And I do have office hours today. So if you email me, I will, I will answer any of your questions. Just remember, don't email me after 8. I don't answer emails after 8. But before then, if you ask me any questions, I'll respond. So, does anyone have any questions before we go ahead and wrap up this lecture?
Where can we find the link to the quadratic YouTube video that you were talking about?
If you look right now, I did it right before class started because I did that last night. I went ahead and just recorded them. You will find them in the sequence of the links at the very bottom. It'll say at the very bottom, lecture 6, quadratic functions. If you look, you'll see it, and if not, just email me. I believe I did it.
You said there was a homework due Monday. I only see a homework due up until Sunday and then on Tuesday.
What's the one that's for Tuesday? Is that the
It's the 3.5. No, sorry. It's the 4.3 quadratic functions and their graphs. That's due
Oh.
Tuesday night at 11:59.
Oh, okay. Then you have an extra day. I'm sorry about that. So you have
Okay.
even more time. So that's my fault. Okay, so that's perfect actually. That's even better. So Monday I'll still have a homework review session for the stuff for the video.
Okay, thank you.
Yep.